My name is Victor Digomore here, and in this class, we are going to be looking at the derivation of cosine rule. The derivation of cosine rule. Remember, in the last class, we have looked at how to derive the sine rule, and then after this class, we are going to now start looking at their applications. We have to do the two at the same time because in application sometimes you use two of them at the same time in one particular mathematical problem. So that's why I want us to do the two derivations. We did the sine rule derivation in the last class, and then in this class I am going to be looking at the derivation of the cosine rule. You pay attention, and you need to follow what I am going to do here. I am not going to be in a hurry. I promise you that. Let's take it. The derivation of cosine rule from an acute triangle. I have already made this label and these descriptions here so that we don't waste time doing that. Okay, now look at this. I will say consider triangle A, B, C. That is this triangle as a whole. Okay. I will now say let. In mathematics, we do a lot of let. Of course, when creation, began, if you are in the same faith with me, there was a let. Let there be light. Okay. So let BM, let BM equals to T. Okay, comma. Then you know that from here, this CB is represented with A, the letter A. That's why we marked it like this. Okay. Now, if from here to here is A, and we have removed this portion BM to be T, all right, what is likely going to be from C to M? Okay, it will be this whole, the whole of this minus this part that will give here. So that's why we say, if we say let this be T, then CM, then CM will be equals to A minus T. Okay, I think that description, that explanation is taken. Now, we now say from triangle, there are two triangles here. Okay, from this part, from triangle ABM, from that triangle ABM, let's bring in something, Pythagoras theorem. And it states that opposite squared plus adjacent squared is equal to the square of the hypotenuse. So you will see that AM squared plus BM squared is equals to AB squared. So this way, I will try and represent the informations that are there. This will now be that AM squared plus that BM is T squared is equals to the hypotenuse is C squared. Okay, let me keep it there. Of course, I can make 5 collect like terms here. We are going to, let me do it over here so that you capture what I'm sure you will see what I'm doing here. AM squared will be equals to, this goes over here, will be C squared minus T squared. I'm sure that is very clear. I am not, fast. so that you understand every step I take here. Let us call this equation 1. Is that okay? All right. Can we come over here and we say also from triangle ACM, we do the same thing, that opposite squared, that is AM squared plus adjacent squared, which is CM squared, is equals to the hypotenuse squared, which is AC squared. Okay. Now we have that AM squared plus this is in bracket A minus T all squared is equals to, then this AC squared is equals to B. We square it. So I have AM squared equals to, let this go over there, we'll have B squared minus bracket A minus T all squared. Do you follow? Okay, this looks like this. So let me call it equation 2. I hope you are seeing what I am doing there. I have been able to generate this equation from this side of the triangle and the second equation from this side of the triangle. Okay, so I have got equation 1 and equation 2. Follow me. Okay, do you realize that AM squared is common in equation 1 and 2? So I will say, since AM squared is common in 1 and 2, okay, equate them, make them equal. So obviously I am going to have B squared minus A minus T squared equals to C squared minus T squared. Does that make sense? Yeah. Now the next thing now is we have to expand this place. Okay, should I be a little bit faster? Let me do something here. You know that this information you have here is the same thing as A minus T in bracket A minus T. You know that? Yeah, it is squared. That's itself, multiplying itself. So here I'm going to have A squared. This times this, you have it 2 times because you're going to have minus. Okay, let me just do it the way, because I promise to help you to understand. So this times this is this, and then this times this is minus 80. This time this is also minus 80. Then minus t times minus t will give you plus t squared. Remember, there is a minus before them, so gather them. We will have a squared minus 2at then plus t squared. So permit me to bring in this one now. I will now have, therefore I will now have b squared minus in bracket a squared minus 2at plus t squared close bracket equals to c squared minus t squared. I'm sure that is not a trouble. Okay, let's move on. Let's open this place with this information here. Minus, we enter here and we have b squared minus a squared minus into minus plus 2at. Then minus into this will give us minus t squared equals to c squared minus t squared. Collecting the terms, if we collect the terms, you will see with me that if this goes over here, it will become plus and they will eliminate each other. So I will take away this and this. Is that too fast? Please capture it. If this goes over there, it becomes plus. Okay, so now we have, let's bring out here 2at and take these ones over there, like this equals to, we will have here a squared plus c squared, then minus b squared. Okay, at this point there is t here, and I want to find out what is happening with this t, what actually is going to be the value for t. So I am going to go back to the diagram. I'm going to come back here. You see there is an information here that could help me to know what this, this is. So I will consider this triangle and say from triangle ABM, that's ABM, this triangle, okay? From that triangle, do you realize, are you seeing with me that cos B is equals to adjacent T over hypotenuse C? Let me show you. You see that this is B, the cosine of this angle is adjacent in this triangle. This is adjacent over hypotenuse, T over C, cos B. I'm sure you have seen that. Okay, so can we cross multiply here? We are not going to have that T is equals to small c, not sine, small c cos capital B. I can give this a label. I have got two equations. Can call this equation 3. Is it 3? No, let me call this equation 3 and call this one 4. Equation 4. So that I can say put 4 into 3. Put equation 4 into equation 3. Okay. Now, if I do that, I want you to see what I'm doing here so that I don't go outside the camera. So let me bring this information over here. So I will have 2 into 3. I will have 2a t equals to. Now this t will be replaced. This t will be replaced because t here is c cos b. So I will write in brackets c cos b. I hope that is okay. Equals to a squared plus c squared, then minus b squared. So obviously what we have here is 2 what? ac, then cos b equals to a squared plus c squared minus b squared. Divide both sides by 2ac. Divide both sides by 2ac. So what you are going to have is 2ac cos capital B over 2ac equals to a squared plus c squared minus, I hope this time around I'm not flying like a aeroplane, 2ac. Okay, so my students in class, they start shouting, wait. If you take away this here and take away this here, you have cos B left equals to a squared plus c squared minus b squared all over 2ac. This is a function, okay? This is a value you're able to get from for cos B. Please look at it again and again. While you are looking at it, I will now bring in the other 5 of these Please, I know you've taken note of this place, so permit me to append the other 5 here. Those other 5, we are not going to derive them. We are going to list them out from what you are seeing there in a very, very simplified way. Yes, if you don't watch this, if you don't look at this, you may not have got all that we did right here, right now. Okay. Now, let me show you what I am trying to say. We have been able to get that. We have been able to get that cos b is equals to a squared. Watch, watch it, watch it, watch it. A squared plus c squared, and you remove the small letter of this b, remove small b squared. Did you see that there? Okay, all over 2 times this and this, 2 times this and this, ac. Now permit me to write cos, now cos a, capital A, cosine of angle A, to be, I'll start with b squared plus c squared. I will remove small a squared. Did you see that? All over 2 times this and this, 2 times b c. Did you notice that? And then that is to say that cos c now will be a squared plus b squared. I will remove small letter c, that's that side, c squared, and divide by 2 times this and this, that is a b. You see that writing these expressions are easy. They are easy if you follow. I'm trying to beat time. If not, I will give you, more detail. I will make out more time, but I'm trying to meet up with time here, so I don't spend more time, doing this. Okay. So I'm sure that these explanations I gave are very, very, the secret has been revealed to you. Now, do you realize that if you cross multiply here, if you cross multiply here, you will return back to this expression. Where is it again? You return back to this, 2ac cos b equals to a squared. Now, do you realize that if you make this b, bring this minus b over here and bring this over here, you will realize that, do it in this a, do it in this a. Let me start with a. You realize that a squared will be equals to b squared plus c squared, then minus 2bc, then cos capital A. If you do that, now look at the one of b. I take this b over here. B squared equals to, you now have a squared plus c squared. Okay, then minus this will come over here and be 2ac, then cos capital B. It then means that c squared, the small side of that triangle, c squared will be, if you're looking for the side, will be equals to a squared plus b squared minus c squared. No, like I'm hurrying now, then mistake is coming. Okay, minus 2ab, then cos capital C. Okay, this 3 is what you use to solve for the angles, and this 3 is what you use to solve for the sides of the triangle that is given to you. Oh, I wish I can quickly and be trying to meet up with time. Now, in the next class, I am going to show us how we apply these expressions in handling a problem. Do we get that? Please, you have to join me in that class so that you see what is going to happen. Okay, please, thank you so much for being there. Just look at it again and again and again, and then you'll be able to understand everything we have been able to explain here. Okay, please, do you like what we did? Was this class helpful to you? Like the video and share it to someone out there, and then subscribe to the channel. That's your way of encouraging us to do more. All right, I thank those of you. I'm very happy with those of you who have already subscribed to the channel. There is a good number of you, and I'm very much grateful for you having done that, and I'm trusting God that more of you are going to do the same to encourage us to grow. Thank you so much for being there.